Dear learners, today we will be able to solve the problem to find the equivalent resistance between the terminals X and Y using the star delta conversion of the given figure. So now we first draw the figure, electrical network. So this is the terminal X, this is one resistor. Now you draw this diagram in this way. This is the network. Here the terminal X and here the terminal Y. We have to determine the equivalent resistor between the terminals X and Y. So these are the values in ohms. This is 5 ohms, 6 ohms, 3 ohms, 9 ohms, 5.5 ohms, 5.5 ohms, and this is 4 ohms. See this diagram. Now we consider this junction is defined as 1. You may consider, and this is the 2, and this is 3, and this junction 4. We are considering there are 4 junctions. So now here we consider the current source at the terminals X and Y. How you select? Now, if the resistance network are given, so which networks are in series and which networks are in parallel? First you should determine. So the process is that, so when you determine the equivalent resistance between these two terminals, we are considering or imagine a current source between these two terminals. As we are discussing the equivalent resistance between the X and Y, so terminals X here and terminal Y here. So we are thinking there is a current source and current comes out in the terminal X and passes through the 5 ohm resistor and reaches the junction 1. This is the junction 1. At the junction 1, the current divides in two ways. One is in this direction from the 3 ohm resistor, another through 6 ohm resistor. As 3 ohms and 6 ohms are in two branches current, from this current here, so we may consider 3 ohms and 6 ohms may be parallel, as because these two current are branching at the junction 1. But when the current 3 ohms current reaches at the junction 2, and this current again divides in the two directions, one is passing through the 9 ohm resistor, another is passing through the 5.5 milli resistance. But when the 6 ohm resistor current reaches the terminal 3, again it divides in the two directions, one is through the 9 ohm resistor, another is passing through the 4 ohm resistor. And these two currents, through the 5.5 ohms currents and through the 4 ohms current, and meeting at the junction 4 and gives another current and reaches the point terminal Y. So entering current through X and outgoing current to the Y. So here the interesting point is that the current in the 9 ohm resistor, as the terminal 2 and terminal 3, you see here, when we are calculating this current, so we are considering the current through 2 ohms, current passing through junction 2 to junction 3. And when we considering the current division from the terminal 3 or junction 3, these two currents passing through 9 ohms and passing through 4 ohms. So as because the junction 2 and 3, you see here, there is a 9 ohm resistance and the direction of the current in both the ways, from 2 to 3 or from 3 to 2. So this is the problem. How will you convert the star delta conversion? So this 9 ohms current as the direction of the current in the reverse two ways. So we should consider either these 3 ohms, 9 ohms, 6 ohms are the delta connections. You may convert to the star equivalent star connection. So, but how will you draw this diagram? So let us consider this is a neutral point, and we may consider this will be the line, and this will be the another line, and this will be the another line. So this will be as a neutral point, and from neutral point to terminal number 1, this is the terminal number 1. So neutral point to the terminal 1, the resistance will be R1, and neutral point to the terminal number 2, this is the resistor value R2, and from terminal number N to terminal number 3, the resistance value is R3. So, and we may remove these 3 resistor values, 3 ohms, 9 ohms, and 6 ohms. These 3 ohms, 9 ohms, and 6 ohm resistor removed, and only keep this is the R1 value, this is R2 value, this is R3 value, and all the 3 resistors of the delta connections, 3 ohms, 9 ohms, and 6 ohms are removed. Now we draw the next connection. How we draw this diagram? So this is the X terminal, and 5 ohms make as it is. This is the terminal 1. So now there is a resistance value. See here this diagram, in the previous diagram, this is R1, and this is terminal 2, this is terminal 3, and this is the terminal 4. So now 2 to another point, we draw the one resistor, and this is the neutral point we may consider here, and you join this terminal 3. So these are the R2 value and R3 value. So when neutral point connect to the terminal number 1, this value is known as R1, and neutral point to the terminal number 2, this value is known as R2, and neutral point to the terminal 3, this value is R3, and this 5 ohm keep as it is. And terminal from 2 to 4, you keep the value as it is, that is 5.5 ohms resistor. And 4 to 3, keep as it is, that is 4 ohms resistor. Now think here, and this is the same value, that is you have drawn here 10 ohms. Is 10 ohms. This is also 10 ohms. So this terminal known as the X, and this terminal known as the Y. This diagram is equivalent to, this is the figure number 1, this is figure number 1, and this is figure number 2. So these figure number 1 and figure number 2 are identical, so that is we define as the equivalent symbol. So the resistances between the X and Y, in that case and in that case both are same, but in this first figure you cannot determine what will be the equivalent resistance. So if we convert this delta connection connected between terminal 1, 2 and 3, make the delta connection is converted to the star connection as R1, R2, R3. So this will be the star connection, and you can simplify, you can determine the R1, R2, R3 value in the simplest way. And for this simplicity, you may join the previous delta value. Delta value is connected here, terminal 1 to terminal 2, terminal 2 to terminal 3, and terminal 3 to terminal 1, that is in this direction. So there is a 3 connections removed. Three connections, three resistors are removed here. From terminal 1 to 2, that was 3 ohms, terminal 2 to 3, that was 9 ohms, and terminal 3 to terminal 1, that was 6 ohms. We remove the 3 resistors of the delta connection and make the star connection, and we have to determine the R1, R2 and R3 value. So how will you determine? So according to the discussion, previous discussion, what will be the R1? So R1 will be the R12. What is R12? So the three, this terminal 1 and terminal 2, this value is the R12. This 3 ohms is known as the R12. And junction 2 to 3, the 9 ohm resistance is known as the R23. And terminal 3 to terminal 1, the resistor 6 value is known as the R31. So here R12 equals to 3 ohms, R23 equals to, so write down here R12 equals to 3 ohms, R23 equals to 9 ohms, and R31 equals to 6 ohms. So we can determine the R1 value of the star. One connection of the star value, that is R1. So R12 into R31 by R12 plus R23 plus R31. So what is the value? So this value is the R12 value is the 3 and R31 value is the 6 by R12 equals to 3 plus 9 plus 6 ohms. So what is the value? 3 into 6 by 18. 18. So 6 and 18 cancel out, 3 and 3 cancel out 1. So this is 1 ohm. So we get the R1 value equals to 1 ohm. So what is the R2 value? So R2 value will be similarly R2 value equals to R12 into R23 by R12 plus R23 plus R31. So what is the value here? So R12 equals to 3 ohms. 3 ohms into 9 by 3 plus 9 plus 6 equals to, you calculate here 1.5 ohms. If you calculate, similarly R3 equals to R23 into R31 by R12 plus R23 plus R31. Denominator, both the cases are same. So here it will be 9 into 6 by 3 plus 9 plus 6. And denominator is the 18 and 9 into 6. So it will be 9, 18 cancel out 2. So that is 3 ohms. So you calculate here R1, R2, R3. So 1 ohms, 1.5 ohms and 3 ohms. So here write down, this is 1 ohms, R1 equals to 1 ohms and R2 equals to 1.5 ohms and R3 equals to 3 ohms. R3 equals to 3 ohms. So now, how will you calculate the total equivalent resistance? So again, you think if there is a current source present in the XY terminals, so current enter into the terminal X and passes to the 5 ohm resistor and reaches at the junction 1. At the junction 1, same current is passing through the R1 resistance. That total current passing through the 5 ohms as well as R1. So 5 and R1 both are in series. And at the junction N, the current branches in two ways. One is passing through the R2, another is passing through the R3. So as R2 is the same current passing through the 5.5 ohms. So R2 and 5.5 ohm are series, and R3 current passing through the 4 ohms. So R3 value and the 4 ohms are in series. and these two networks meeting at the point 4. That means R2 plus 5.5 and 3 plus 4 both are in parallel because there is a two branches at the terminal N. So as the two junctions meet at a point 4, that between the N and 4 there are two networks. One is R2 plus 4, 5.5, another is R3 plus 4. These two networks are parallel. After calculation of the parallel, you add the 10 ohm resistance because all the current, main current passing through the 10 ohm. So 10 ohms would be the parallel. So how will you calculate? Now write down the note here, RXY. So the R equivalent between the terminal X and Y. So 5 plus 1, see the diagram, this is the 5 plus 1, 5 plus 1 here, this is 5, this is 1, so you add 5 plus 1, then R2 plus 5.5, R3 plus 4 are in parallel, so there is a configuration, this is plus 5, 1.5, that is R2 value plus 5.5 is also given parallel R3 value, that is 3 ohms, that is R3 value. So 3 plus 4, these two branches are parallel. So taking the bracket, whole bracket. After that 10 ohms, as because 10 ohms total current passing through the 10 ohms, so 10 ohms would be series. So what is the value here? After calculation, this is the 6. This is the 6 plus 5, 7 parallel 7. See here, plus 10. So 6 plus 7 parallel 7 means divided by 2 any one of the resistance, that means 3.5. If you calculate 7 into 7 by 7 plus 7, you will get 3.5. So that means when two resistances are similar values are in parallel, so it will be the 50% of the one value. That is the 7 by 2 means 3.5 plus 10. So how much value here? 19.5. 19.5 ohm. So RXY. So RXY, what is the value? Equals to 19.5. So 19.5 value. This is the R equivalent values between these terminals X and Y. See here again. So as the current passing through the X passes through the 4 ohms and same current passes through the R1 ohm. That means 5 ohms and R1 are in series. As and when it reaches the network N, terminal junction N, it have two parts. One is passing through R2, another is passing through. As these are two branches, these two branches will be parallel if the two branches meet at the same point. Here the same point is known as the 4. That means R2 current is same as the 5.5 ohms current, and R3 plus 4 ohms are same current. So R3 plus 4 are in series, and these two series are parallel, and after that you add this 10 ohms, so we will get this R equivalent value 19.5 ohms. So in this way, how will you calculate power? When and where you apply the star delta network? You see this figure number 1. If see here terminal number 2 and terminal 3, there is one resistor value 9 ohms. And when we divide the current distribution pattern, 2 ohm from the terminal junction 2 to terminal junction 3, there is a one direction current, and terminal junction 3 to terminal junction 2, there is another junction current. As one resistor, there is two waves current are present. So we cannot determine the resistor either it be series or in parallel. So from this conclusion, we make this is a delta network and it should be converted to the star network. If we convert this star network, then you can easily calculate the equivalent resistance using this configuration or using the star connection from the delta connection as given in the previous parts R1, R2, R3. So R1 will be the R12 into R31 by R12, R23 plus R21. So how it is R12 into R31? As the terminal this is 1. So this is the resistance R1. This is the resistance R1. So R1 means the product value of this junction 1, 2 resistor 3 ohms and 6 ohms, that is 3 into 6. When you calculate R2, that means at the junction 2 there are two resistors, one is R12 and the R23. So the numerator is R12 into R23. When you calculate R3, so in the terminal junction 3 there is two resistors, R23 and R31. So numerator is R23, R31. And denominator both the cases are same. So using this formula we can calculate 1 ohms, 1.5 ohms and 3 ohms. So using these three values, you put here this diagram and you can easily calculate R equivalent resistance. So this is 9.3. So in this way you can easily calculate the R equivalent resistance. In the next video, we will discuss another complicated electrical network using star delta conversion process. Thank you.